So, the first thing we are going to do is look at 1 through 6, where it does not ask us to simplify anything. It simply asks us for the excluded values. So, excluded values here are the points that you cannot have in your domain. So for rational functions, that's going to mean anything that would make the denominator zero. So if we look at that first example there, we're not actually going to simplify any. It's not asking us to do that on number 1 through 6. It's just asking us to find whatever's going to make the denominator 0. This is much like we did with our discontinuities with our rational equations, right? We don't have to know whether it's a whole or a vertical asymptote. We just need to know anything that would make that denominator 0. So you're going to take whatever your denominator is. In this case, it's 12x. You're going to set it equal to 0 and solve. In this case, it is just 0. So our excluded value would be x equals 0 for that first one. Okay. If we look at examples, or number 3, we've got m plus 7 over m squared plus 4m minus 21. So again, we are looking at what would make that denominator there equal to 0. How are we going to figure that out with an expression like m squared plus 4m minus 21? That's a quadratic like you were doing on your homework last night, right? So we could, there's lots of ways we could do it. We could complete the square. We could use quadratic formula, but I believe this one is going to factor, and I think most of them will factor that you're going to see here. So if we factor, we would have a plus 7 minus 3, I think, for that. And remember, that is our factored form, but for our actual numbers that are excluded, we would have to do m equals negative 7 and m equals positive 3. Those would be our excluded values. Okay, and let's do number 5, and then we'll move on to simplifying. So for 5, we've got 35x minus 35 over 25x minus 40. So again, just looking at the denominator, we need to know where that equals 0. We have a pretty simple linear equation here. We're just going to add 40. 25x equals 40. We will divide by 25. And that will reduce, both of those are divisible by 5, so we'll get 8 fifths. So our excluded value would be 8 fifths. Okay, any questions so far? 1 through 6, it's always asking for, you got to give the excluded values. It's not asking you to simplify. But past number 6, it's asking us to simplify and state the excluded values. So if we just look at number 7, we've got p plus 4 over p squared plus 6p plus 8. You need to do excluded values first before you simplify. Because sometimes things are going to simplify, that's going to make us miss one of those excluded values because it's going to cancel out. So it would be perfectly fine to go ahead and just factor this first. And so if I factor that denominator, I should get a p here and a p here, plus 4, plus 2. So my excluded values would be p equals -4 and p equals -2. Now, whenever we're simplifying this, one of the big things you must know is when you are simplifying, stuff has to be multiplied together for you to be able to cancel it out. So, for example, what a lot of students may want to do, lock this in place so I can erase it, is they may want to say, before they do anything, they might be like, oh, there's a p right here. I'm going to mark it out with one of these p's in the bottom. They might even reduce, like, oh, I'm going to reduce this. That'll be 1/2. Okay? You cannot do that whenever you have these plus or minus signs in between the things that you are canceling there. So I cannot mark out that p on top and bottom because that p is separated from the rest of the stuff in the top with a plus or a minus sign. So we cannot cancel like that. In order to cancel, we have to have multiplication between the things that we are canceling. So if we factor, like we have done over here, that means we've got multiplication right here. And what I want to cancel, I'm canceling this entire expression, p plus 4. So I'm not canceling just the p or just the 4. I'm canceling that entire expression. So I can cancel it with the top and the bottom there. Because the in between the things that I'm canceling here, I've got multiplication for that. Does that make sense, the difference? Okay, so once those cancel, you would still have like a 1 in the top because you have to have something in that numerator. So we would have 1 over p plus 2. And that would be our simplified version of this. But notice that I said you need to do excluded values first, because if you wait till the end, you're going to lose that -4. And that -4 is still an excluded value, because it would give you a hole in your original graph if you were looking at that as a function. Okay, let's look at number 9. I've got 2a squared plus 10a over 3a squared plus 15a. How do we factor that? There's a better way than putting a plus 0 on the end. You could do it, but there's a better way. We can just pull out a greatest common factor, whatever we could just like pull out of the top and pull out bottom by just dividing both of those. So in the top, I got a 2a squared and a 10a. I could pull out a 2a. So I'm dividing 2a squared by 2a. I will just get an a whenever I do that, and then I'll get a plus 5 over here. If I multiply that back, it gives me 2a squared plus 10a. And then for the denominator, to factor that, I would do 3a times a plus 5. Now, before I cancel anything, a lot of times it's helpful to go ahead and factor, but before you cancel anything, you want to look at that denominator and do your excluded values for this problem. So 3a cannot equal 0, which means a cannot equal 0, and a plus 5 cannot equal 0, which means a cannot equal negative 5. So you got those two excluded values there, 0 and negative 5. Instead of writing excluded, if you just want to put like a cannot equal this, that'll cover it. And so here I've got multiplication between everything. 2 times a times the stuff in the parentheses. 3 times a times the stuff in the parentheses, right? So anything that matches top and bottom can cancel. A plus 5 and a plus 5 can cancel. This a right here and this a right here can cancel. I will just get 2/3 as my answer. So what that means is no matter what number I plug into this, I could plug in 1, I could plug in 7, I could plug in 55, I'll get 2/3 no matter what number I plug in. Unless I plug in 0 or negative 5, because that will give me a 0 in the denominator, which will be undefined. Okay, questions? All right, let's flip over to the back side and do some of the ones that are a little bit tougher. Let's look at number 15. No, let's do 16. Let's do 16 instead. 16 is n plus 3 over n plus 2 divided by n minus 1, n plus 3 over n minus 1 squared. So, this one's already factored for us. We don't have to factor it. We do need to look for excluded values. So, denominators cannot equal 0. So, that's going to give me an n cannot equal negative 2 from that first term right there. Then n minus 1 squared, you really only get 0 for that if n minus 1 equals 0, so that's going to be n cannot equal positive 1. How do we divide fractions? Flip the second and multiply. So dividing fractions, easy as pie, flip the second and multiply. So that is going to make this look like this, n plus 3 over n plus 2 times n minus 1 squared over n minus 1 times n plus 3. So that second fraction flips. Here is something that's unique to a division problem. Now I've got a new denominator, right? So I can't have a 0 there either because it's going to cause a 0 in the denominator in that second step where I flip and multiply. So I already have n cannot equal the negative 2 from here. I already have the n cannot equal 1, but I also need to add to my excluded values n cannot equal negative 3. So to multiply fractions, I just multiply across the top and multiply across the bottom. So really it's like, this is really like one big fraction. If I wanted, I could put some parentheses around this stuff. All of this stuff is just multiplied together. So it is okay for us to cancel. You also may want to think of this n minus 1 squared is like having, it's like having n minus 1 times n minus 1, like that. There's 2 of them. You don't necessarily have to rewrite it like I just did, but that's how you want to think of it. So you're going to cancel one of these n minus 1s, but not both. And then you could cancel this n plus 3 with this n plus 3 over here. So you will get n minus 1 over n plus 2, and that will be your answer. We're going to do one more together, and then I'm just going to let you guys do your work, and then we may start our notes. We'll see. Especially since I know tomorrow's up in the air. So we're going to do 25. X squared minus 16 over 9 minus x times x squared plus x minus 90 over x squared plus 14x plus 40. So it's going to be to our benefit to factor everything. So this will factor into x plus 4, x minus 4. We'll leave this alone. I'm going to have x plus 10, x minus 9, for that numerator there. In the denominator, I'll have x plus 10, x plus 4. And so before I start canceling anything, I want to look for excluded values. So for the x plus 10, I'll get x cannot equal negative 10. For the x plus 4, I will get x cannot equal negative 4. And then for this 9 minus x, I'm going to get x cannot equal 9. You'll notice I didn't take the opposite sign on that 9 minus x. It's because of the way it's written. If that was equal to 0, you just add that x to both sides, and 9 would equal x. You can also just think, what number, if I plugged it in there, is going to give me 0. And 9 minus 9 will give you 0. So you want to do excluded values before you start canceling. Now we can cancel. I can cancel this x plus 10 and this x plus 10. I can cancel this x plus 4 and this x plus 4. Now, 9 minus x, x minus 9. Do those cancel? They're not the same, right? Because subtraction is not commutative. We cannot switch the order, but they're really close to canceling, right? Like all I need to do is switch the order, and they would cancel. So there is a way that we can get these to cancel, okay? And that way is that we can factor out a negative 1. So if I take 9 minus x and I factor out a negative 1, it is just going to change the sign of both of those terms. I'll have a negative 9 and a positive x. Is it okay for me to turn this around and write it as x minus 9? That is okay, right? So, if you ever have 2 and it's a subtraction problem, and all you need to do to get it to match is just to switch the x and the y's, you can do that by factoring out a negative 1. So that'll look like this. The top will be x minus 4, x minus 9. In the bottom, we will have negative 1 times x minus 9. And so now the x minus 9's match, and I can cancel them, which will give me x minus 4 divided by negative 1. What you will probably see on the answer is that we just go ahead and divide both of those by negative 1, which will give us negative x plus 4. Actually, the answer key on the book does this. They kind of move that. When you have a negative like that, you can put it in top or bottom or out front. They do it like this, negative x minus 4, like that. Any of those 3 answers right there would be correct, though they're questions? Okay, I'm going to give you guys about 15 minutes to work on this, and then we are going to do 1 or 2 questions from the stuff that I want to start tomorrow, just at the end of class, so everybody's seen it a little bit. That way my work keys, kids, if you guys don't come back at all, you've at least seen a little bit, and we've got like a very beginning. You won't have any homework with it. I just want to do a couple for that. So take a few minutes to do a few of these. We may not have time to finish it all in class. You'll finish it for me for homework if you don't. And then we're going to do a few problems together.